Hi everyone, welcome to the last example that we're going to do here in our 6.3 notes. And this is example 3 at the bottom of your page. It says graph the system of linear inequalities, describe the solution set, and then pick one possible solution, because there will be many. When I look at this problem, I see it's a system because there are two inequalities that I have to graph. And so the first thing I do when I look at this is to say, okay, well, here's going to be the first linear inequality that I'm going to graph. X plus y is greater than or equal to 10. Right away, I'm looking over here to see what kind of numbers these are. Okay, these are whole numbers. And I know that whole numbers are 0, 1, 2, 3. So there's only positive values. So I'll say plus here to mean positive. Only positive values for x and for y. Okay, the second linear inequality that I'm going to graph. Okay, well there's going to be the boundary line, y is less than x. And again, I have whole numbers. Okay, so this is true for both of my lines. If I only have whole numbers, if you think about your graph for a second. Okay, here's your y-axis and here's your x-axis. If you only have whole numbers, that means you can only have positive values for x. So your graph is going to be on this side, okay, of the x-axis. And you can only have positive values for y, so you're only going to be on this side here. Okay, so above the x-axis, positive values for y. So you are going to end up with, your graph is only going to be in quadrant 1. Okay, so you are restricted to quadrant 1. That's always going to be true anytime you see either natural numbers or whole numbers, okay, for x and for y. So you're going to be restricted to quadrant 1. Okay, let's go ahead and graph this. So on your next page, you've got a little bit of room. And when I graph it, I am going to want to rearrange those linear inequalities to get them into slope-intercept form. Okay, so let's do that. So I'm going to graph one of them in red. Okay, and this is what I'm given. X plus y is greater than or equal to 10. Okay, before I graph that, let's get that into y equals mx plus b form. So y equals mx plus b tells me that I have to get my slope in my x as well as my y-intercept on the right-hand side of that inequality symbol. So I think of like a little wall right there. I have to get this. This is 1x. I have to get it over to the other side. So let's move that over by either exporting it or subtracting x from both sides. And I will have y is greater than or equal to. Now it's going to be negative x. I'm going to put it in front of the 10. Okay, plus 10. So I'm all done. Okay, that's what I'm going to be graphing. A couple of things I know about this all right away just by looking at it. I know that my boundary line, okay, is going to be not a dashed line. It's going to be a stippled line. Okay, remember that we're working with whole numbers here. So we are working with discrete data. Okay, so our solution set will be discrete. So this boundary line, okay, this tells me that I will have a stippled line. Okay, and then I'm going to stipple the plane above the line. Okay, so we could go ahead and graph that right now. I've given you a little bit of a different graph paper in your notes because there's no sense in graphing using a graph that has all 4 quadrants. We might as well just go straight to quadrant 1 here, okay? So I'm just going to put a straight line here for my y-axis as best as I can, okay? And then there can be my x-axis right there. Okay, and so this graph starts at 10. There's my b value. Okay, so let's put some numbers on our graph here. So over on the side, we can make each one of these squares worth 1. So I'm just going to put 1, 2, 3, 4, 5. Okay, there's 5. I'll go up by 5. There's 10. Okay, counting up another 5. Okay, there's 15. And There's, oops, sorry, there's 20. Okay. And there's 25. Okay, good. So I've just separated that out. And I could do the same thing on my x-axis. Let's make each square worth 1. So we can label them 5, 10, 15, 20. Okay, oops, sorry. Okay, there's 5. There's 10. 15. Okay, that looks good. We can stop there. Okay, so let's graph this. I'm going to graph it in red. And I'm going to start at positive 10 on my y-axis. So that's right here. I'm going to put a data point, and I'm going to use the slope to do the rest of my line. So it tells me, remember what your slope is here, negative x, your slope is equal to negative 1. Well, that's just like, negative x is just negative 1x. Okay, if I just come in here for a second, fix that up a bit. Okay, that's just negative 1 over 1. So that's my slope, down 1 over 1. Okay, so let's do that. Down 1 over 1, down 1 over 1, down 1 over 1. Okay, and you can continue to do that, or you could get out your ruler and you could put a straight line there and just simply staple every point on that line. Okay, so there is our first, we've graphed our first linear inequality. Let's do the next one. Okay, going back to our question for a minute, we had to graph 2 of them. We just graphed this one, now we have to graph this one. Okay, y is less than x. Okay, so let's do that. I need just a little bit more space here. You've already got this written down, so I'm just going to erase on my board here. Okay, and I'll put the next linear inequality here. Okay, so here's the second linear inequality that makes up my system. Y is less than x. Okay, this is kind of an interesting one. You have a y and you have an x. So this is not some line that goes through a value of, you know, y equals 3 or y equals 1. This is a line, okay? The trick here is recognizing that you are told this. I can rewrite this like this: y is less than. What's the slope? Okay, there is a number in front of that x. It is a 1. So 1x. So this is just 1 over 1. Okay, a rise of 1 and a run of 1. What's my y-intercept? What's my b value? Well, nothing is given, so that just simply means there's a 0 here. Okay, if there's nothing there, it's just plus 0. In other words, this graph starts off at 0 down here, okay, and it's going to go up 1 over 1. So we can go ahead and graph that. Be careful when you do this. We can put our data points in, but let's remember that this is going to be a dashed line because it is a strict inequality. There's no little equal sign under that. So I'll start here at 0, and I'm going to go up 1 and over 1. So up 1 over 1, put a little data point there. Up 1 over 1, up 1 over 1. I apologize, you guys. My pen's not very good, but you can be doing this right now on your graph as well. Okay. Right here, they're going to intersect. I'm going to use an open circle. Okay, up 1 over 1. Okay, and I could stop now. I could carry on. Okay, so let's connect that line with a dashed line. Okay, just like that. A little bit different than my other stapled line. And now let's shade these. Let's go back and shade them. So my first boundary line that I drew, okay, was the line y is this line right here. Okay, this was y equals negative x plus 10. But the linear inequality was y is greater than, okay, negative x plus 10. So that tells me I'm going to shade above that line, okay, or actually staple above that line. So I'm just for the moment just going to say let's put those little lines in just to remind me that I would be going above that line. And if you had your pencil crayon, this is where you could shade using a pencil crayon above that red line. Okay, and then when you're done, you'll just staple the overlapping region. The blue line, if I come back here, okay, the blue line, I know I have to staple below the line because it's a less than sign. Y is less than. So this one I'm going to staple below. And so for now, I could use my pencil crayon, or I could simply just go like this just for the moment, just to remind me that when I do fill it in and staple it, it's going to be below that line. Well, where do those two lines intersect, or where do those two shaded regions overlap? The only place they overlap will be below the blue line and above the red line, which is going to be right here. Okay, so all the whole numbers. Okay, and if that line had continued, we could, you could have continued it all the way off your grid if you wanted to. Okay. So it's all of this area, and clearly that's a lot of area to staple. That's why I say it's fine to use a pencil crayon or a highlighter. Just show that this is the overlapping region. Okay, but because we have discrete data now, we are going to just staple in that region. Okay, so I'm going to staple everything on my red line is already stapled there. Okay, and then any data points, okay, any whole number coordinates, so that's where the grid lines meet, okay, in that solution region. And again, you can just start your stapling. You don't have to staple absolutely every single point in the shaded region because that's a lot of work. Okay, so everywhere below that dashed line and above that stapled red line. Okay, on the whole coordinate, on the whole numbers. So my solution set, if I were to describe it, okay, it's the whole number coordinates, or whole numbers, on and above the boundary. So we can say it's going to be whole numbers, okay, on and above, well, on and above the red line, right? So on and above y equals negative x plus 10. Okay, and below, now I'm not going to say on and below the blue line because I know that the blue line was a dashed line. So only below that line. So below the line, y is equal to 3. Okay, and it does not include the point of intersection. So I do need to say that. Not including okay. Okay, not including the point of intersection. If you go back to your graph and ask yourself what was the point of intersection, it's right there. Okay, if you read the coordinates for that, it's 5 for x and 5 for y. So it's the 0.55. Okay, so not including the point of intersection, which was the 0.55. Okay, use an open circle right there. Finally then, one possible solution. Okay, well, any of the possible solutions are any of those points that you stapled in your shaded, overlapping shaded regions. So you could pick anything you wanted in there. Okay, so for example, I could pick this point right here. Okay, any of those whole numbers, this point right here. So let's just pick this point just for the sake of argument here. On my x-axis, that's at 11, and on my y-axis, that's at 7. So one possible solution would be the point 11,7. In other words, that point would satisfy both of those linear inequalities. Okay, and that would be a possibility. That's it for now, folks. Thanks for joining me. Good luck on the questions. See you next class.